Is it recording? Yep. Okay, so last lesson I introduced a new statistic called the interquartile range, abbreviated as IQR. And when you run this into the CAS calculator, it won't give you the IQR. You'll need to calculate it yourself. So we need a formula. Beck, do you remember the formula for the IQR? Excellent. So visually, this is the interquartile range here. If I draw an arrow between Q1 and Q3, that's the IQR there. And this represents the middle 50% of the data set. I should say the spread of the middle 50%. So in today's lesson, one of the things we're going to do is we're going to draw two box plots on the same graph. And we're going to compare them. So one of the things we want to compare is how spread out a box plot is. Because some box plots will look like this. Others will look like this. Maybe you can guess which one's more spread out. First one or the second one? The second one. Okay? And we'll also look at the median as well, but we already know what the median is. It's the middle line of the box plot. Okay, I'm not going to go over this in detail now, but just want to remind you, last class we also defined something called an outlier.
I have a question.
Yes.
Why isn't a median in the middle of the box?
Great question. Excellent. So the reason is because the median represents the middle number when you ordered the data from smallest to largest. So even though like a quarter will be here and a quarter will be here, the 50th percentile of the middle number could be anywhere between those two numbers. Okay. So if it's symmetric, then it will be in the middle. But if it's skewed, that is positively skewed, like this one, will have a bigger spread in one direction. Yeah. Okay. These are outliers. Those are the dots or the crosses to the far left or right of the box plot. And last lesson, we also introduced a way to define whether or not a data point is an outlier. So you might need to refer to your notes for this. So flip back a couple of pages in your book. What did we need to do to check whether or not there were outliers in the data set? So Bruce has said outside the fence. That is a step in the right direction. There are two fences. Ash. Yeah. So it's an outlier if you are A, below the lower fence, or B, above the upper fence. Now, if you've forgotten this isn't going to be very useful because you might not remember what the lower fence and upper fence is. Last Friday, but you might have been at swimming. That's why. Okay, so let's go blue for this one. It's just a dot point. Okay. So the lower fence equals, does anyone have it handy? Because if you tell me the answer, it shows me that you wrote notes last lesson. So 1.5 IQR is what we need for both. Excellent, that's right. Okay, Q1 take 1.5 IQR, Q3 plus. It's all right, John, you win some, you lose some, but you'll win next time. Okay. So, year 11, if you get this is a big win for me as a teacher because we spend a lot of time worrying about this early in the year 12 course, and then we quickly go off onto a new topic for about 4 weeks. So, if you understand this year, you'll have a much easier time next year. So I know you might already have the diagram down, and that's fine. Just wanted to go over it again because A, some of you are away, and B, I know that we forget. All right. So, is anyone still copying? No? Okay. So, notice now we have two box plots on the same scale. So, this can happen, for example, if you do an experiment and you have a control group and an experimental group. So maybe you give a drug to one group and you don't give a drug to the other group, and then you compare whatever you're interested in. How long the tooth is for tooth growth, run time to finish a race, whatever experiment you want. Okay. Um, it's very easy to see any differences between the two groups because last time we just had the numbers. And with just the numbers, it's very hard to see differences in the shape or the distribution of the data. But with the box plot, it's very easy. We can see straight away. So I'll just draw in the median because it's not very clear on the screen. That's the median. So one question that we want to ask as statisticians, which you all are, you're all statisticians doing statistics, is whether there is a difference between the two groups. So have a look at the box plot.
Wait, what are the lines out the end of it mean?
Ah, good question. So Emily has asked, what do the lines coming out of the box plot mean? I will throw it to the class. Does anyone remember what that is? Beck.
One side is the largest value, which is not an outlier,
That's right.
and then the other one is the smallest.
So Emily, because you missed last lesson, if you have an outlier, it'll appear as a dot at the end of a box plot. But there's no dots here. Oh, uh-oh. Okay, we're good. So if there's no outlier, then the line will extend all the way until the largest value. Okay? So this is actually the maximum here. But if there was an outlier, this would be the largest value in the data set that is not an outlier. So there's actually a few steps to do to check that, but that's the big idea. Not an outlier, largest value. Not an outlier, smallest value. Okay. All right. So, Maddie, we are looking at the two box plots on the screen, and one question that I want to ask is whether there's a difference between the two groups. So, what do you think?
Yeah.
You think there's a difference? Okay, please expand.
There's more homework.
Okay, which group has more homework?
Because
Does every year 12 student have more homework than every year 8 student?
probably not, but this is grouping them all together.
So, is there a statistic that you could use to demonstrate that maybe on average the year 12 group has more homework than the year 8 group? Very nice. So, our first clue that there is a difference is the fact that the medians are far away from each other. So, the first thing you want to look at when comparing box plots, there's 3 things you want to check. So, write this down. This will be relevant for next year as well. The first one is the center, which is the median. Okay? All right, are there other differences that people can see in this box plot? Quartiles are smaller. Okay. Let's explore that more deeply. So The median is actually a quartile as well. The median is the second quartile. On the previous page, I defined a statistic involving the first and the third quartile. Do you remember what that was? What was Q3 minus Q1?
Q, the lower two.
No?
Q median.
No?
Median.
No?
IQR.
IQR is correct.
Yes.
Now, you got it correct after guessing several times.
Actually, I told her that.
Okay. Now, what was the interquartile range all about?
Um,
Why did we bother calculating that? What did it measure for us?
median.
Say it again.
Median.
No, we've already got the median. I've circled the median already. I'm interested in the interquartile range.
Isn't it like how spread out the data is?
Yes.
See how smart I am. How spread out the data is. Is that the median 50%?
Okay. So, there are three things on this checklist. The first one is the center. And to assess the center of the data set, you need to use the median. You can't use the mean because the mean is sensitive to outliers. So one outlier on one side will heavily shift the mean one way. So the median is considered more robust as a statistic for skewed data sets. So you must use the median. Please do not use the mean. Okay? Spread tells us the middle 50%. How spread out is the data? So is the spread the same? Is it different? Is one group more spread out than the other? Not a trick question. Your 12 is more spread out. And this is a homework thing, right? It's a bit light, actually. Anyway, I didn't say that. Your 12 really should be doing more homework than that. So the year 12s are more spread out. There's a larger spread in the amount of homework done. The median is higher. That's not surprising because they have more homework. And the last thing you want to look at is shape. So by shape, I mean skew or symmetry. Including outliers. So if there are outliers in your data, it's a good idea to refer to them as well. So let's look again at the box plots. How would you describe the shape using one of three terms? Symmetric, positively skewed, or negatively skewed? Let's start with the year 12 box plot. How would you describe the shape of that one, Ben?
I don't know, actually.
It's okay? Does anyone want to not give Ben the answer, but help him to decide whether the box plot has one shape or the other? What should we look at to decide skew here?
Would it be where the median is in the plot? Or no?
You can use that. Yeah. We need a bit more information than that, though, to make a decision.
Aren't both of them negatively skewed?
Negatively skewed. Okay, so you put out an answer, AJ. Can you justify why it is negatively skewed?
Because both of them are the latter most of this side.
Yes, the spread is larger in the negative direction. So this is 25% of the data here. This is another 25%. Can you see that the spread is larger on this side? It's larger in the lower values or the negative direction.
So it's negative.
Yeah. Okay. So this one is negatively skewed. And what about the year 8 group? How would you describe the shape of that one? Yeah, so this one's a bit subjective. If you look at the middle 50%, I would say it's negatively skewed. But if you look at the whiskers, it's actually larger in this direction. So I actually don't know with this one. But let's just go with negatively skewed. Oh, actually, no. No, I think we have to go with positively skewed. Because if we go to the, if we go back to the histogram will have this shape. So you'll have a lot in the middle, and then you'll have a long tail towards the top here. And this is positively skewed. So scratch that. Don't just look at the middle. Look at what we call the whiskers of the box plot as well, which is the lines coming out. Okay. So just to repeat, don't just look at the middle. Look at the whole box plot, and obviously don't include the outliers. Okay, so this question just asks you to read off the median and the IQR. Do you want me to do that for you, or are you good? So I haven't actually answered the question. I've just sort of taught you stuff. Do you want me to do the question with you? Or are you good?
What are we doing today?
We are doing this exercise, which is 2I. No, you can work on it tomorrow and Friday, because this is the last part of the textbook for this chapter. Do you have Vico?
No, I don't think so, but I'm not going to be here. Neither am I.
How come?
Neither am I. Because I have a Sam event.
Okay.
And Emma's going to Stephen event. Yeah. And Tara's coming as well. I'm going.
We're all one big happy family, it seems. Nice. Okay, well, so hands up if you want me to do this question. Okay, Mac, I can do the question with you. One-to-one tuition. No one else wants it. So, that's actually it for statistics. So I'm going to modify the work program. I just want you to do questions 2, 6 to 8, and 10. Don't worry about the rest, because the main thing from this section is the box plots. Yes. So next week on Tuesday, your assignment is due, and you will sit a test on statistics. Just wait 1 second, Tara. So next week, your assessment for this topic happens. You must hand in your assignments. Girls, can you just wait? I'll say it again. Next week, assignments due. Test is during class. And tomorrow and Friday, you will have time to do some private study. So I'll just be here to help you.
Do we have a class tomorrow?
For 1 period in the morning.
Yeah.
All right, so I want to remind you that statistics is a major topic in the Year 12 course. I can't recommend that you do Year 12 general maths without passing the test next week. So I will let you resit the test as many times as you like, but you've got to pass the test to do Year 12. Okay? All right, please get started on Chapter 2.